In the name of Allah, in this lecture we will explain the insulation resistance test and the polarization index test. And in the next lecture we will explain the tan delta test, also called the dissipation factor test, although both the insulation resistance test and the tan delta test are carried out to evaluate and determine the condition of insulation in transformers. Through some practical experiments, we will make a comparison between the insulation resistance test and the tan delta test. We will understand what the difference is between them and whether one of these tests is better than the other or not. In other words, we will find out together whether we can eliminate any of these tests or if it is necessary to perform both tests on power transformers. And of course, all of this will be through some practical experiments. At the beginning, it is very important to understand that the quality of transformer performance is considered one of the most critical factors for the successful performance and proper operation of the electrical power system. Since transformers during operation are continuously subjected to unexpected factors and disturbances in the electrical network, these factors may affect the performance quality of the transformers. Moreover, these factors can also cause a reduction in the service life of these transformers. That is why one of the most important objectives of the maintenance engineer or the testing engineer is to carry out electrical tests on power transformers on site periodically. This is, of course, to detect transformer defects in the early stages, or as it is often said, predicting the fault before the disaster occurs. And of course, after that, these defects are repaired before the transformer or the electrical network is exposed to any unexpected faults or potential risks. Naturally, everyone knows that the main components of the transformer are the iron core, the high voltage windings, the low voltage windings, and then the insulation system inside the transformer, especially the mineral insulating oil. Of course, the insulation system has the function of providing insulation between the iron core and the low voltage windings, between the low voltage windings and the high voltage windings, and between the high voltage windings and the transformer tank or the main transformer vessel. Therefore, we must know that the insulation system inside the transformer is divided into two types: liquid insulation, solid insulation. As we already mentioned, the liquid insulation is the mineral insulating oil. But the solid insulation includes, for example, varnish for covering and insulating the wires from each other. Also, cellulosic paper, which is used around each copper turn as an additional insulator, and also cellulose boards, which are used for insulation between the high voltage windings and the low voltage windings. In a brief and quick way, we can say that the most important tests carried out on power transformers on site are as follows. Regarding the main tests performed on the transformer windings, they are winding resistance, turns ratio, polarity, short circuit impedance, Z%, or impedance voltage, Z%. We will discuss these tests in detail in upcoming lectures, but in general, we can say that these tests are performed on transformer windings to ensure that no displacement or movement of these windings has occurred from their original position. This is, of course, due to the transformer being subjected to mechanical stresses caused by high short-circuit currents, for example. Also, through these tests, any broken connection, short circuit between windings, or insulation damage of these windings can be detected. As for the most important tests performed on transformer insulation on site, they are insulation resistance, IR, polarization index, PI, dissipation factor, or tan delta, power factor, or cosine theta, partial discharge, PD, dissolved gas analysis, DGA, chemical analysis, and Furan analysis. But in this lecture, we will focus on the insulation resistance test and the polarization index test. Let us concentrate together on a very important point. If you are performing resistance tests, whether winding resistance or insulation resistance, you must know that the measured resistance value does not represent the actual true resistance value during transformer operation. This is because you must understand that resistance value is highly affected by temperature. Therefore, as everyone knows, we have two types of resistance. Conductor resistance, such as the resistance of the copper windings inside the transformer, and insulation resistance. You must know that the resistance of the conductor is directly proportional to temperature. The resistance of the insulation is inversely proportional to temperature. This means that with increasing temperature, we notice an increase in the conductor resistance value and a decrease in the insulation resistance value. Therefore, it is extremely important to perform temperature correction for the resistance values being measured, whether winding resistance or insulation resistance, and compare them with the values obtained from the factory tests. We emphasize that transformer temperature in the summer is not the same as in the winter, and transformer temperature during operation is not the same as its temperature during testing while it is offline. All of these conditions cause changes in the measured resistance values. For this reason, thermal correction must be carried out at a specific reference temperature, and this is done using specific tables available with all testing engineers. At the beginning of the lecture, I mentioned that the main components of the transformer include the iron core, which consists of 3 phases. Then, after that, comes a layer of proper insulation, followed by the low voltage windings, which are cylindrical in shape around the iron core and also 3-phase. Then comes another layer of proper insulation, followed by the high voltage windings, which are also cylindrical in shape surrounding the low voltage windings. Therefore, we understand from this that there exists an insulation system between the iron core and the low voltage windings, the high voltage windings, and the transformer tank, or the main transformer vessel. Of course, everyone knows that any 2 conductors separated by an insulating material form a capacitor. Therefore, since the iron core, the low voltage windings, the high voltage windings, and the main transformer tank are all conductive or metallic materials, you can imagine the size and number of capacitors that exist inside the power transformer. Consequently, you must realize that these capacitors have a significant effect, especially during lightning surges and switching operations. First, the insulation resistance test, or IR test. The insulation resistance test is carried out to ensure that the insulation condition between transformer windings or between the winding and ground is good. This ensures the absence of any impurities, moisture, or contaminants in the transformer oil. This test is performed using the Mega device or a DC voltage source of, for example, 1000 volts, 2500 volts, or 5000 volts. The value of the test voltage is, of course, determined according to the voltage rating of the transformer. For example, in the case of high voltages, such as 66 kilovolts, a Mega device with a DC test voltage of 5 kilovolts is used. Using the Mega, a DC voltage is applied between the high voltage windings and the low voltage windings, as well as between the high voltage windings and ground, and between the low voltage windings and ground. In each case, the current flowing is measured, or more precisely, the leakage current through the insulation is measured. By applying Ohm's law, where resistance R equals voltage V divided by current I, the insulation resistance value can be obtained. Of course, the insulation resistance R is usually in the range of giga-ohms, or sometimes hundreds or thousands of mega-ohms. Thus, the higher the insulation resistance value, R, the better the insulation quality, which means the insulation is dry, free of moisture, and does not contain impurities or contaminants. It is extremely important to pay close attention to the effect of temperature on the measured insulation resistance value. As I mentioned earlier, insulation resistance is inversely proportional to temperature. This means that if the temperature increases by 10 degrees Celsius, the insulation resistance will decrease to half its value. For example, if the insulation resistance measured at 20 degrees Celsius is 2 gigaohms, then for the same transformer, if the insulation resistance is measured at 30 degrees Celsius, it will be observed as 1 gigaohm. Likewise, if the resistance is measured at 10 degrees Celsius, it will be observed as 4 gigaohms. That is why it is very important to carry out temperature correction for the measured insulation resistance value and then compare it with the factory test values at the same reference temperature. I mentioned earlier that the insulation resistance value is calculated by dividing the applied DC voltage by the current flowing through the insulation. However, to have complete and correct information, it is very important to understand that when a DC voltage is applied across any insulating material, 3 types of currents will flow through this insulation. The first type is the capacitive charging current. To understand the source of this current, it is very important to know that transformer windings have resistance, inductance, and also capacitance. As I explained earlier, transformer windings together with the insulation between them form capacitors. Although the effect of these capacitors is neglected during normal operating conditions, they become significant in some transient cases that transformers are exposed to, such as lightning surges and switching operations. From this, we understand that when a DC voltage is applied across the insulation, which behaves like a capacitor, a large current flows initially. This current is consumed in charging the capacitor until it completely disappears once the charging process is finished. The magnitude and duration of this current depend on the transformer size and rating. In other words, this current is directly proportional to the transformer size or the rated power of the transformer. The second type of current is the absorption current. This current results from the changes that occur in the molecules of the insulating material due to the application of DC voltage. These molecular changes cause current to flow through the insulation. This current can last for a period ranging from a few seconds to several minutes, especially in large power transformers. The third type of current is the leakage current. This type of current appears with a stable and constant value as soon as the DC voltage is applied to the insulation. Therefore, dividing the DC voltage by the value of this current gives the actual insulation resistance value of the transformer. From this, we understand, and we must pay close attention to this point, that in order to obtain an accurate and true result from the insulation resistance test, it is very important and absolutely necessary not to take or record any readings of the leakage current until both the capacitive charging current and the absorption current have decayed to zero. Accordingly, the insulation resistance value is measured after 15 seconds and also after 60 seconds of applying the DC voltage by dividing the voltage by the current. We can also calculate the dielectric absorption ratio, DAR, by dividing the resistance value after 60 seconds by the resistance value after 30 seconds. The acceptable value must be greater than 1.2. As I mentioned earlier, in order to obtain accurate results for the insulation resistance value, the leakage current should not be recorded until both the capacitive charging current and the absorption current have decayed to zero. Unfortunately, in the case of large power transformers, the absorption current may persist inside the transformer for a long time. That is why many experts recommended resorting to the polarization index PI test. The polarization index PI test requires a time period not exceeding 10 minutes. A DC voltage is applied, and after 1 minute, the insulation resistance value is calculated by dividing the DC voltage by the current. Then, after 10 minutes of applying the DC voltage, the insulation resistance value is calculated again. Thus, the polarization index, PI, can be obtained by dividing the insulation resistance value after 10 minutes by the insulation resistance value after 1 minute of applying the DC voltage. It is very important to know that the polarization index test is a relative test, meaning that it can be performed even without waiting for the capacitive charging current and the absorption current to decay to zero. It is also very important to know that the polarization index test is not sensitive to temperature. In other words, with this test, no temperature correction is required for the measurement results, since, as I said, it is a relative test. As for the permissible values, a high polarization index, PI value, between 1.1 and 1.3 is an indication of good insulation condition. However, if the polarization index, PI value, is less than 1.0, this is an indication of impurities, moisture, poor insulation condition, or severe deterioration of the insulation. In the next lecture, we will explain the tan delta test, also called the dissipation factor test. Although both the insulation resistance test and the tan delta test are carried out to evaluate and determine the condition of transformer insulation, through some practical experiments, we will make a comparison between the insulation resistance test and the tan delta test. We will understand the differences between them and whether one test is better than the other or not. In other words, we will find out together whether we can eliminate any of these tests or whether it is necessary to perform both tests on power transformers. Thank you for your attention. See you in the next lecture.